Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Abqari bin Abdul Razak. We are from Control Department. Today we will be presenting about our department progress. For our department, we focused on the throttle of the engine, the indicator panel for the driver, and the fuel storage. All these act as input in moving the airboat and also showing the output of the condition of the airboat. This is our department organization chart. So I will be showing the design. So here is the pedal assembly. The pedal here is the input. Force will be applied to the pedal. Spring here will act as an opposite force when pushing the pedal. As the pedal rotates, it will pull the throttle here that connected to the engine. Next, here is the fuel tank assembly. This here is the cross section of the tank showing the flow inside the tank. The last one is the indicator. The indicator is where the output will be showing. The box here is where we will be installing the speedometer showing the speed, tachometer showing the RPM of the engine and the fuel gauge. And here is the full assembly. The pedal is positioned in front of the driver's seat and connected to the main chassis using the M8 board. The fuel tank is connected to the linkage, which the linkage is welded to the main chassis. And here is the indicator panel. The aspect view of one of our components, which is the pedal assembly. This is the asymmetric view. So here we can see all of the view from asymmetric view, front view, top view, and sub view. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Kashab Abdul Rahim from Department Control and Safety. So today I would like to present to you about fuel tank. So what is fuel tank? A fuel tank is a safe container for flammable fluid. Though any storage tank for fuel may be so called as fuel tank. The term is typically applied to part of an engine system in which the fuel is stored and propelled or released into an engine. Okay, so this is what our fuel tank look like for the airboat. The power source we use is petrol. The dimension of this fuel tank is 550 millimeter length, about 300 width and 300 height. Okay, so the capacity for this fuel tank is 49.5 liter. That is about 13 gallon. The fuel tank itself weight about 5 kilogram without fuel, and with an estimated weight about 50 kilogram with fuel. Okay, so next I would like to show to you the calculation how we get the capacity of the fuel tank. Okay, as I mentioned before, we got the volume of the fuel tank, so we can calculate the capacity of fuel for the fuel tank. That is how the calculation look like. So next I would like to present to you how the fuel tank work. So this is how the fuel tank work. What we got in the fuel tank is a float that connected to the gauge, and it will show how many fuel left in the fuel tank, and it's connected to the fuel gauge. That is from me. Thank you.
Assalamualaikum. My name is Haris bin Ghazali. So for indicator panel, there will be 3 type of indicator that will be used. So the first one is boat speedometer, which is to determine the boat speed. The second one is boat tachometer, which is to find out the boat's engine RPM. And the third one is float fuel tank gauge, which is to determine the amount of fuel inside the boat's fuel tank. So the first one is boat speedometer. The main component for this is speedometer. So there are two main factor that should be considered when using boat speedometer, which is the speed of the water and the air pressure from the water. So these two will be used to calculate the boat speed. So a pedometer use a pitot tube. So the pitot tube will be put at the back side of the boat that will be touching the surface of the water. So there are two holes at the pitot tube. One hole is to measure how fast water is moving through the tube, and another one is to measure the pressure of the water. So the air pressure will be fluctuating up and down once it hits the water surface according to the speed of the boat. The variance in water speed and pressure is then translated into the speed shown on the boat speedometer. So the next one is boat tachometer. It has an input. So the input is the engine, boat engine. So output is AC voltage proportional in amplitude to the speed, and this is then decoded by the tachometer. The variation in speed give a proportional change output voltage, therefore a change in meter reading. There will be some kind of variation in the terms of the RPM of the engine. So the last one is fuel gauge. So there will be a float inside the fuel tank. So the float will float on the fuel surface. So it will indicate the fuel level. So when the float is at its lowest, the resistance value in the circuit to the gauge is almost zero. So we will have a simple circuit from the float to the gauge. So it will react, the gauge will react according to the float. So all of these three indicator will be using battery. So that's all for me. Thank you.
Assalamualaikum. My name is Muhammad Fidas Afiq bin Asman. Today I will present the controls in Tinkercad's Arduino. Some electronic components can be simulate using Tinkercad's Arduino. Tinkercad circuits allow anyone to virtually create and program Arduino projects without the need for physical hardware. Arduino is an open source electronics platform based on easy to use hardware and software. Arduino boards are able to read inputs such as light on a sensor, a finger on a button, turn it into an output such as activating a motor or turning on an LED. This is our speedometer, this is our distance sensor, and this is our fuel gauge indicator. And now let's go to the Tinkercad website to run some simulations. Firstly, the speedometer. Let's run the simulation. In the first 2 seconds, an Airboat speedometer will light up in this LCD as static value. Push the buttons to activate the motor. This potentiometer will simulate the throttle. The more the operator twists, the more power it gives to the motor, the more RPM the value has. This will link directly to the Arduino board and to the LCD. As the throttle increase, the speed also increase in kilometer per hour. Next is the distance sensor. This distance sensor basically helps the operator to dock the boat or to avoid obstacle. When obstacle is within the ultrasonic sensor, the buzzer will turn on. These two buttons will adjust the sensing distance. At default setting, it is at 20 cm, which means when there's an object within 20 cm in the sensor, the buzzer will turn on. If we don't want 20 cm, we want other value, we can set it here. And now when the sensor detects object within 40 cm, lastly, the fuel gauge. This potentiometer will simulate the level sensor. The level sensor basically detects by using buoyancy force. When the level sensor is detects full level of fuel, all of these LED will lights up. As the fuel level decrease, the level sensor will change its potentiometer, reducing the voltage and reducing the LED lights up. And lastly, only blue LED lights up. Blue LED indicates reserve fuel in the tank. That's all for my presentation. Thank you very much.
Assalamualaikum. My name is Muhammad Fahmi bin Besar. Today I will present about engineering analysis. Okay, calculation on pedal. This calculation is to determine force needed on the pedal when we give the force on the pedal up to 30-degree angle. This is on static position. This is the value of spring length and the value of wire throttle length. We do the analysis when force applied on the pedal is up to 30-degree. Factor of safety of spring. The safety of spring we use is 2 and the maximum load is 58.84 Newton. To get the design load, the maximum strength we divide by 2 and we get 29.42 Newton, and it's approximately 3 kg. Force on pedal spring. We use formula F equal to Kx. K is spring constant and X is length. Final minus initial length. And we get the force 2.275 Newton. And to get F1, we calculate using trigonometry. This. And we get I get 0.844 Newton. And force on carburetor was spring. We also use the same formula, which is 100 times 0.179 minus 0.157, and we get F 2.2 Newton. And F2 we also use trigonometry, and we get the value 0.614 Newton. The total force needed to push the pedal to 30-degree is 1.458 Newton. Okay, 1 meter stress analysis. This arrow we can see is the pressure we give to the pedal. This is the spring, and this is the throttle wire. This cable throttle is located is a little bit bent here, and we can see the red area is the most pressure is applied because of the spring when we push the pedal, and the blue one is the most safe, which is it can overform. been have damaged. Okay, that's all. Thank you.
As a conclusion, all of the design parts within our department works together to aid other departments to complete the mechanical inner workings. The pedal acts as a throttle to control the engine's RPM. Fuel tanks responsible to provide power source into the engine. The indicator panel works as a means to inform the vehicle operator about their vehicle current status. That's all from our department. Thank you.